I am not teaching, I am publicly learning. But hi and welcome to Learning for the Life in the UK test part 157, Some Great British Inventions of the 20th Century, part 7. It is on page 56. While doing leg injury prevention training, if you participate in the leg injury prevention training, better set your own risk. Before we go to the Some Great British Inventions of the 20th Century, part 7, we're still on the page, I want to talk about something. I was thinking, do I still know the numbers of the medieval times? And I think that were 467 until 1485. So it told us that the 467 after Christ was the end of the Western Roman Empire. Now, if the second number is 1485, that would be the same number as the Battle of Bosworth Field. (1485). Broadly speaking, the Middle Ages spans 1,000 years from the end of the Roman Empire, 467, up until 1485. That means, if it's not a coincidence, 1485 is the year of the Battle of Bosworth Field. That was the war-ending Battle of the Wars of the Roses, 30 years long Wars of the Roses, in which the House of York fought against the House of Lancaster. House of York, the White Rose, King Richard III. Wait, was that King Richard III? If I'm not wrong, King Richard III is the person of whom the remains were found 10 years ago. And the parking lot, famously. But that's another story. So King Richard III and the other one, Henry Tudor. And they're the first Henry Tudor. And then we start on the next page with the Tudors and Stuarts in here, King Henry VIII. So that means they've chosen for the end of the medieval times the begin of the Henrys and Tudors on the British throne. Because we were wondering a couple of times about that, where that number comes from. So there are multiple different ways to say when the medieval times ended. One of them, I said, was the end of the fall of Byzance, or the invention of gunpowder also, or the discovery of America. They have chosen the Henry Tudor, the Tudors on the throne of the English throne. One would not do that for Spain, the end of the medieval times in Spain, or in France, or in Italy. So there, someone would take something else when who came on the throne in Britain as the end of the medieval times. They have chosen the 1485, if it's not a coincidence, the year of the Battle of Bosworth Field, and the first Tudor, Henry Tudor, as Henry VII on the British throne. And the other thing is, I think it was King Richard III, of whom the remains were found, I think it was 2012, in a park, on a parking lot. So, now to part 7, and we had already as inventions made in Britain, or done in Britain, or by British people, the television, the radar, the Turing machine, co-discovered insulin, the structure of the DNA molecule, the jet engine, the hovercraft, the Concorde together with France, the Harrier jump jet, and the cash dispensing ATM, and the in vitro fertilization therapy, and now we're having dolly the sheep. So, in 1996, two British scientists, Sir Ian Wilmot and Keith Campbell, led the team which was the first to succeed in cloning a mammal. I'm just wondering about the punctuation. Cloning a mammal, dolly the sheep. This has led to further research into the possible use of cloning to preserve endangered species and for medical purpose. So in 1996, was it that two scientists, and they were British, that's important, otherwise it wouldn't be listed here. So, British scientists, Sir Ian Wilmot and Keith Campbell, they two were leading a team. And that team was the first one who was successful to clone a mammal. So all types of animals who feed their kids, their younglings, with milk. So sheep, for example, do it. Humans also. So a mammal. That is important because mammals are seen in biological sense as more complex, or something like that. So it was not cloned a single cell, or a plant, or we had made two the same tomatoes or something like that. Now we made a mammal. an animal which feeds their younglings with milk. We have made a sheep. So two scientists, they were leading a group, and they cloned a sheep. This has led to further research into the possible use of cloning to preserve endangered species and for medical purpose. Yes, it can be also used to preserve endangered species. So the idea is, if there's a species where the little are off, or if they are extinct maybe even, but the DNA can be taken from them, this DNA can be copied, and then an animal can create it which has the same DNA. So it's basically a twin, as far as I know it. So it's not the same sheep, no, but it is a twin. It has the same DNA. It has the same setup, like two twins. They look the same. They are not the same person, but they look the same. They have the same set to be built after, which humans normally don't have, and also all the other sheep and mammals and horses don't. That can be used to maybe save endangered species, but it's more for the use of medical purposes, or maybe even first things which are not named here. So for medical purposes. Ich should know where that would be useful. If is it the way to that be useful for humans, as for humans to clone. I can see it in medical research. It's medical purpose. Whatever, cloning. So basically, to be able to make a twin. And the living twin, Dolly the sheep lived. It was a living sheep. It was successful. Now, that is cloning. And now we're going to do the complete leg injury prevention training. And we don't have time to come through. We will do... I don't know. We will do now the leg injury prevention training in the next 4 minutes. And during these 4 minutes, we will do nothing. So if you participate in leg injury prevention training, this is the honest. Having a leg set out apart, we're breathing in. And out. And in. And out. And in. And out. And the last round, breathe in. And out. Close the legs. And we're doing the first exercise. We're having a good standing leg. We're bringing the other leg into the air, and we're swinging it to the side and in front, side, front. The leg is straight, the foot is flexed, and the toes are pointing more or less the whole time straight in front. A few more. And now we're doing the same with the other leg. The leg is straight, the foot is flexed, and the toes are pointing more or less all the time in front. A few last ones. And now the next exercise, again a good standing leg. And the other foot is flexed in the air. And we're bringing the foot front and back, front and back. And we're doing it quite fast. And now with the other foot. Again a good standing leg. The other foot is flexed in the air. And we're bringing the leg front, back, front, back. And the next exercise. We're bringing one leg up into right angle, a flexed foot, even like hips, down to on one side, having yes, even like hips, and we turn it back. And now we're breathing in and out, and we're bringing the leg to the outside. And we're breathing in and out, back into the middle, and contract down. And we'll get the leg up, we're breathing in. And we're breathing out, we're bringing the leg to the outside. And again in. And out, back into the middle. And contract down. Now with the other leg, we're bringing the leg up, right angle with the leg, flexible even at hips. Turn it back, breathing in. And out. leg to the outside, the breathing in, and out the leg back into the middle, and contract down. And the leg up, the breathing in, and out, the leg to the outside, the breathing in, and out back into the middle, and contract down. Now the next exercise, we are bringing one leg up, same setup, and now we're pressing with moderate force on the inside against the leg. Riding with the leg, flex foot, even line hips, toward the back, and a little bend in the elbow. And a little longer. And now over to the other leg. Same setup, riding with the leg, flex foot, even line hips, toward the back, little bend in the elbow, moderate pressing. For a little longer. And now the last exercise, the leg up, same setup, and the knee presses up to the side, up to the side. Even line hips, tall up with the back, the knee presses up to the side, up to the side. Now with the other leg up, riding over the leg, flex foot, even line hips, out of the back, and the knee presses up to the side, up to the side. And the knee presses up to the side. Now the closing exercise, breathing in and out. Again in and out. Again in, out. Close the legs and out. Now we're done with the leg injury prevention training. Doing 3 minutes left. I was always wondering why the remains of a king would be found under a parking lot. But now it makes sense, because he died during a battle. He had not a big funeral. He died during a battle, and this was also able why it was possible to find these remains were through research, because one could make research where was the battle. And I heard something about that. It were the remains of someone, of a king died in a battle. Maybe I'm wrong, but I think it was that story. Sir Peter Mansfield, 1933-2017, a British scientist, is the co-inventor of the MRI, magnetic resonance imaging scanner. This enables doctors and researchers to obtain exact and non-invasive images of human internal organs, and has revolutionized diagnostic medicine. I don't want to talk too much about it because it's quite wide used, and I don't know details about it, but let's go through what we have. So, Sir Peter Mansfield, he was a scientist, British scientist, and he was a co-inventor of the MRI. And MRI is the acronym of magnetic resonance imaging. And it is a scanner. So this scanner enables doctors and researchers to obtain exact and non-invasive images of human internal organs. So non-invasive means we don't need to cut the human body open, and we can still look inside it. And that happens through this magnetic resonance imaging. I don't know how it exactly works, but it is a very strong magnet. That is why there's no metal anywhere allowed. And that somehow makes magnetic somewhere. Magnetic is harmless, so that is why it's no problem. And it's a very strong magnetic field, and it gives a resonance, and that whole machine presents then in the image, something like that. The thing makes a big magnetic field, a big like a magnet, and that magnet, the organs then are giving a resonance where they are, and that is taken as a photograph. So with that thing, with these magnetic resonance waves or whatever these are, where is it possible to see the internal organs of the brain and so on. Without that, anything has to be cut off. So, and the last thing, the inventor of the World Wide Web, Sir Tim Berners-Lee, born 1955, is British. Information was successfully transferred via the web for the first time on the 25th December 1990. So basically the internet, the World Wide Web, was invented by Tim Berners-Lee, Sir Tim Berners-Lee, who is a British citizen. And for the first time successfully to send something over the World Wide Web, so over the internet, was on 25th December 1990. So we're having television, radar, Turing machine, co-discovered insulin, structure of the DNA molecule, jet engine, hovercraft, Concorde, Harrier jump, jet Concorde together with France, cache depensing ATM, introverted fertilization therapy, cloning, MRI, and the World Wide Web. I thank you very much, and next time.